Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck, and today we're going to be talking about functions again. This time we're going to be talking about compound functions. It's going to get a little bit weird, but stick with me. By the end of this lesson, it's going to make perfect sense. Let's get started. As you see here, I've written two functions on the board using the function notation that we learned last time. If this looks unfamiliar to you, please go ahead and take a look at that previous video where I talk about that. But to summarize, this right here, we say this is f of x, this is g of x, and both of those are synonyms for y. They're just another way of writing y. The reason we write them as f of x and g of x is because y doesn't really have any meaning apart from x. Whenever I want to know what number y is, I need to know what the x is first. So by having this notation, I have the x embedded in there. So to see if you remember what we did last time, I'm going to give you a couple quick practice problems. You're welcome to pause and try this on your own. I want you to see if you remember how to do this. So what I want you to find is what f of 10 is, and what g of negative 3 is. If you can solve both of these on your own, you're ready to watch this lesson. Go ahead and press pause and try it right now. Now, as a reminder, when I have the f here, that tells me that I'm talking about this first function, the one that is defined by the f. The 10, notice it's replacing the x in the problem, so that means every time I see an x in this problem, I'm going to replace it with a 10. And then I'm going to evaluate. So what this would say is, all right, instead of a x, I'm going to write a 10, and I want to see what that equals. Remember to put it in parentheses whenever you substitute something in. Very important for this lesson. So for here, I would have 3 times 10, or 30. 30 minus 1 is 29. So the answer to this first one should be 29. G of negative 3, what this is telling me is I'm talking about the second function because I have a g here, and this x has been replaced with a negative 3. So what I'm going to do is I'm going to replace all the x's in that function with a negative 3. And again, you put it in parentheses and just solve. Negative 2 times negative 3, that's positive 6, plus 6, that gives you positive 12. Again, if you got both of those, you're ready for this lesson because we're going to get a little bit weirder right away. Now again, the concept of a function is that I'm taking something and I'm putting it in for x and I'm getting something out, an input and output. So is there any reason why I have to put in a number? Okay, this is algebra, right? So when was the last time we did a problem that only had numbers in it? Yeah, right? Like the very first day of class. So actually, you don't have to put just a number in here. Let me show you what we can do with this, and I want to see if you guys can figure it out. As you can see here, this looks very different than the last problem that I did. Instead of a number, what's in the parentheses is an expression. An expression is simply something that has numbers and or variables in it. So I have an expression in here and both of these functions. Now, if you guys can solve this one, go ahead and try it on your own, but if you can solve this one, I'll be very impressed because you're going to be in great shape to do really well on any functions test that you're going to come up against. Go ahead and try it right now. Press pause. Now, I'm hoping you guessed how to do this, but notice every time we did this before, I had a number in the parentheses and the x was replaced by what was in here. Now I don't have a regular number, but that actually doesn't change the process. Everything that's in the parentheses is going to replace the x in the function. So let's see what this looks like here. So if I want to find f of 2a, I'm going to go up to my function, and every x is going to be replaced with a 2a. So the entire function here now is 3 times 2a minus 1. That's something I can simplify, so let's go ahead and finish this one. 3 times 2a, that's just going to be 6a. Let's see if I can write correctly. If you're familiar with my channel, you'll notice that I make mistakes all the time. Try to fix them though. Math isn't about not making mistakes, it's about learning from them. And as you can see, I caught myself before we got too far in this problem. So this ends up being 6a minus 1. Now, you might want to try to simplify this farther, but you can't. I didn't give you any number for a. I didn't tell you anything else. So all you can say is that the function f of 2a is equal to 6a minus 1. And that's as simple as you can get with this. With g of negative 3w, again, same thing. I'm replacing the x with a negative 3w. So that means everything in my function is going to be every x in my function is going to be replaced with a negative 3w. And again, I put it in parentheses, really important there. And now I'm going to see if I can simplify this a little bit. So I've got negative 2 times negative 3w. That is a positive 6w plus 6. And that doesn't simplify any farther. So g of negative 3w can be simplified to 6w plus 6. Now, I can't do any more with that problem. I don't know what w is, so your answer would simply be that. It's in the expression 6w plus 6. So you can plug in whatever you want into a function. You can plug in any kind of crazy thing that you might imagine. So let's go crazy here. Let's put something that isn't even an expression in. Let's see if you guys can solve this. Now, I don't know how you're supposed to solve f of a picture. We would do the same thing. You want to plug that picture in for x in all of your function, and then see what you can do to simplify it. In this case, we clearly couldn't simplify it anymore, but maybe you could do something a little creative like this. All right, if you're sticking with me, we're going to get even more intense now. I'm going to try something here that is a challenge for many Algebra 2 students, but if you can do this one, you're going to be in great shape and you really understand functions and how function notation operates. Let's try this one. I want to know what f of g of x equals, which is even hard to say. This is called a compound function because there's more than one function in the problem. Now, you can pause this and try it right now, but I'm going to go ahead and explain this. So what we have here, what I see some students do is they say, okay, well, I've got an f of x, and the x has been replaced with a g of x, which is the right answer. So you might start by saying this. This is the same as 3, and then I'm replacing the x with a g of x. And that's the right answer, which is awesome. Except that you can do better. Because here's the thing. You know what g of x equals. G of x equals this whole function here. So what you want to do, instead of plugging in just the notation g of x, is actually replace the g of x with what g of x is. So instead of this, I'm going to replace this whole thing right here with what g of x equals, which means I'm going to have 3. And remember, every time you substitute something in, please use parentheses. It will avoid a lot of mistakes. Negative 2x plus 6 goes in the whole parentheses because that's what g of x equals. And don't forget that minus 1. Just because there's no x doesn't mean it's not part of the function. Now we can simplify again like we did in the other problems. I would distribute the 3 in here, which would give me a negative 6x plus 18 minus 1. 18 minus 1 is 17. So when I'm all said and done, f of g of x equals 6x plus 17. Because I am putting the entire function g of x is replacing the x in the function. A couple of quick notations here. Some books will not use this notation. They'll have it written in a different way. Personally, I don't like that notation, but here's what you might see. You might see this. You might see f g of x, something like this. And it's usually like a little O there, and what this stands for is f of g of x. It means the same thing. The one that comes first is the function that would be on the outside of these parentheses, the next one there, and then the x comes next. All right, you guys can handle this. I've got one more, even more challenging one that you might see. All right, now this one's even more complicated. So let's break it down and see what we've got going on here. Again, if you want to pause and try, go ahead. Right here, I've got g is my big function, and inside the g, instead of an x, notice the x is gone. It's been replaced with f of 2. Now, what we did before is we said, okay, I'm going to replace every x with the whole function. In this case, it would be negative 2 times the function f of 2 plus 6. Notice the x in here has been replaced with what the x is in this problem, which was f of 2. Now, it can get a little bit more complicated, though, because we know what f of 2 equals. F of 2 is this up here. So I can replace f of 2 with whatever the heck f of 2 actually equals. So we can go ahead and do that. You can plug 2 into your function for f of 2, find out what it equals. Actually gives you a number. So f of 2, 3 times 2, that's 5, or 6 minus 1 is 5. So I can actually replace f of 2 with what f of 2 equals, which is a 5. Negative 2 times 5 is negative 10, plus 6 is negative 4. So g of f of 2 is equal to negative 4. And again, all we're doing here is we're replacing what's inside the parentheses. We started with g of x, we replaced the x with f of 2, found out what f of 2 was, and replaced it again. So it's this nested, it's almost like a set of Russian dolls where you have them nested inside of each other. And you can do this as many times as you want. If we had a third function, I could stack 3 of them together. Now, the other notation that you might see in some textbooks looks like this. It would be g of f of 2. It means the same thing as this. Again, I like this better because I think it tells you more information and explains the process better than this. But you might see it, so be prepared. This and this mean the same thing. The first step I would do if I got this problem would be to transform it into that, so I knew what I was supposed to be doing. So that is compound functions. You can nest functions inside each other a bunch of times, and you can solve problems. Do remember, though, the one place you might get tripped up is to make sure that you put it in parentheses when you substitute it in. If you're not doing that, you're going to very likely make a mistake. So please be careful with it. Thanks for joining us. Hope to see you guys next time.